Hello everyone. This is the mechanics of material course. And in the last video, we show you how to use the Cartesian vectors. Okay, how to use the Cartesian vector in 3D space. And here, this video is just one more exercise about using the Cartesian vector in 3D space. And okay, let's start with this. It's also a finding resulting force, very similar to finding resulting force. We say two forces shown in this figure, and you want you to find the magnitude of the force two, and it's coordinated direction angles. That means directional cosine. So that the resultant force, and he said give you the information. He said the resulting force Fr is at along the positive y-axis and has a magnitude 800 newtons. Okay, so let's start with his. Okay, what's the information he give us? Okay, so he give us a F1. Okay, and here he's given the magnitudes. Okay, so the magnitude of force one is 300 Newton. And here he also gives some information about the directional cosine or directional cosine of these force F1 force vectors. He give you the F1 force vector, the angle between the x-axis and F1 force vector is 45 degree, and the angle between the F1 force vector and y-axis is 60 degree, and the angle between the force one vector and z-axis is 120 degree. Okay, it just give you the alpha, beta, gamma. Okay, give you alpha, beta, gamma. That means it give you the direction of cosine. Okay, and the direction of cosine. If you have direction of cosine and the magnitude of the force, you can get the force vector, right? Did you remember that? Yeah, I write an equation. Not equation. We say the force vector is equal to magnitude times the direction, right? And it's a unit vector of cosine. And actually, the unit vector, sorry, not unit vector of cosine, unit vector of force. Okay. And actually, and previously we said the unit vector of the force actually is equal to cosine alpha I plus cosine beta j and plus the cosine gamma k. Okay, so this first one it give you the alpha, beta, and gamma. That means it give you the unit force, the unit vector of the force. Okay, so you have a unit vector of force. Okay, and also get a magnitude. So eventually you will get the force vectors. Okay, so let's say okay. So let's calculate the u the force one, unit vector force one. Okay, so actually it's cosine 45 degree I plus cosine 60 degree J plus cosine 120 degree K. Okay, so it's, I think, cosine 60 degree. What's the value of cosine 60? Yeah, I need a calculator. Okay, 0.5 J plus what's the cosine? Cosine 120. Okay, okay, so that's minus 0.5 K. So actually we have the unit vector of the unit vector of the force one vectors. Okay, so the force one vector is actually 300 times its unit vector. Okay, so what's the value? Okay, 300, and yeah, we need a really need a calculator. Okay, or what's the, yeah, I need to divide by 2 times 300. Let's say is equal to 112I plus 150J and minus 150K. Okay, that's the F1 force vector. And he said, okay, you want to determine F2 and and give the information of the resultant force. So the resultant force is the first vector. Okay? F2 But give information of resulting force factor, and want you based on the F resulting force factor and F1 force factor, you can determine the F2 force vector. Sorry. So here is that Fr is 800 Newton and act along the positive y-axis. That means, okay, let's skip the unit first. So it's positive y-axis, so it's J. Okay, so that's the resulting force vector. Okay, and we have resulting force vector in F1. Okay, so what's the F2? So actually, the force 2 vector is equal to resulting force minus force 1 vector. So the vector addition and subtraction, if we using Cartesian vector, actually is very easy. It's component minus component. Okay, x component minus x component, y component minus y component, z component minus z component. So eventually we'll still have I, J, and K. Okay, let's subtract what's the x component of this resulting force vector. So actually, resulting force is equal to zi plus 800j plus zk. So x component, x component of the resulting force is 0 minus x component 212. And y component 800 minus 150. Z component is z minus 0 minus 1 minus 150. Okay, so finally we got our first two vectors minus 1 to 212i plus 650j and plus 150k. Okay, so that's our first two vector. And he wants to specify the magnitude of the force 2 and its directional cosine. That's very annoying, right? We still need some calculation, so I erase this part. Okay, so back to what we just did. We want to find the magnitude cosine. So what's the magnitude of the force 2 vector? It's very easy, right? So it's minus 212 square plus 650 square plus 150 square. I think the answer is probably 700 Newton. I think the answer is 700 Newton, right? Let me see. Let me see. The correct answer, I think it's 400 Newton. Minus 212 Yeah, I think it's 700. Okay. And the directional cosine. Okay, so okay, let's see. What's the cosine alpha, cosine beta, cosine gamma? Actually, if you remember that the cosine alpha, cosine beta, cosine gamma is just the x component divided by the magnitude. Component divided by the magnitude. Okay, so yeah, I just erase this part. Okay, so so hmm. So what's the cosine alpha? I say it's the component divided by magnitude. And cosine beta, component divided by magnitude. Cosine gamma is component divided by magnitude. Component, what's the component of F2 force vector? Minus 212, 650, and 150. And use your engineering calculator, you will get alpha, beta, and gamma. Okay, so I think I don't need to waste time to calculate this answer. You can try yourself. I just write down the answer directly. Well, it's 108 degree. Alpha is 108 degree. So beta is 21.8 degree. And next one is 77. Gamma is 76 degree. Okay, it's just also another example to show you the use of 3D Cartesian vector and use the directional cosine. Okay, the vector equal to magnitude times the direction, and the direction is just the unit vector of the force vector, and the unit vector is just cosine alpha I plus cosine gamma cosine alpha I, cosine beta j, and cosine gamma k. Okay, and cosine alpha, cosine beta, cosine gamma is just your component divided the magnitude of your vector. Okay, that's it. Just remember this relationship. Okay, this will help you on 3D space calculations. Okay, so let's just start video here. And we are going to the next section. Okay, see you then. Bye bye. Okay.